Hey gang, all right, I'm going to try to do a quick little video here on making the overall body of the program for the CNC manual mill programming exercise for class. All right, we've done the definition of profile. We also have done a short video on speeds and feeds. All right, so once those classifications of variables are defined, it's really just time to sit down and knock out writing the body of the program. And that is, right now you might not think so, but it is pretty simple. So I'm going to go through it with my common blocks of programming approach. Okay, so I'm going to share my screen here using the whiteboard. Okay, so hopefully this will work. Okay, so having worked lab 2, you know that G91, G30, Z0. All right, what does that do? That does the move Z to tool change position. Okay, that moves the Z to the tool change position. How does it move the Z to the tool change position? Well, incrementally, it does it incrementally. That's what G91 means. G30 is reference position number 2. So our tool changer on the machines here at the college uses reference position number 2 as the tool change position. Some of the newer Haas's they're all using G28 because their reference position 1 can do the tool change. And you're moving the Z axis to the 0 position. So that's how you would read that whole line. But as you're getting started, just remember that whole block together. If you can memorize the whole block together, you'll remember it to write it in a program. Okay. All right, so here's the way we invoke a length offset. G43, H, and a tool number. Well, let me write it like this. How do I want to write it? Just do 2 blank lines. G43, H, and a move along the Z axis, somewhere to within an inch, okay? Because you'll see how you're normally within rapid tool motion at this point, okay? But what's this block of code do? It turns on length offsets. Okay, it turns on length offsets. All right. So where H is the call to the register page, to get the real number, that you found. Okay, it gets the tool offset. H follows tool number. That is not a CNC requirement. That's not a requirement from the RS 274D format. That is more like a company policy. So I know if I'm getting tool 1 and I need to use a length offset, tool 1's length offset is H1. All right. Tool 5's length offset is H5. It's just that easy. G43, H, Z, 1 inch. Now, why do I move into Z? I move into Z because I'm invoking a length offset. You always want to make a move. So we turn on and off offsets on the move, whether they be for Z, whether they be for X or Y. So CDC values, fixture offsets, tool length offsets, whenever you're making a change, invoking something or disvoking something, you want to put the X, Y, or Z, or X and Z, or all 3 of them on the same block that you're making that machine function change to, so the machine does not need to move too far. All right, because normally when you try to invoke or disvoke functions, and not command the axis to move, those functions will make the machine move, but those moves are usually too large, bigger than the machine offset, the machine envelope, and will over travel the machine, all right? So G43, H, and a number that is the same as the tool number, Z 1 inch, because that 1 inch gives you a nice visual effect. You know, you're in rapid motion, you'll see the machine stop for a little second and then continue on. If you're not within that inch, when the rapid move is over, you know, you got a split second, microsecond to stop the machine if there might be a problem. Okay, remember, we don't pump and pray around here. Those that have been in know what I mean by that. Okay, a CDC call, G41 or 42, all right, left or right. All right, so CDC is G41, which is left, or G42, which is right. Okay, let me put my parentheses around there so you don't think that's part of any common block. All right, and then a D and a number, X, Y. Okay, this invokes CDC. Now, just like we have the rule for H, we have a rule for the D. All right, the rule for the D, which is company policy, not RS 274D standards. All right, it's company policy. We want the first shift and the second shift to work the machines the same way. All right, D, let's say we, for Camden County College, 50. All right, so 50 plus the tool number, 50 plus tool number, okay, equals register number of the CDC. All right, just that easy. All right, G41 or G42, D, and then a move in X and Y. All right, because you are turning on an offset. Okay, now one of the most important lines of code in the program is called the header. We call it the header. All right, and the header will set up the machine to a known state. All right, there's a couple different ways you can be calling a program. It could be the first program of the day or night, depending upon what shift you're on, or you can be getting into this program off the end of another program's execution. So you need to make sure you know how that machine is going to react. So you usually want to put some of the common G codes of the different groups of G codes that we know of, all right, such as, all right, one you don't know about, G80, that cancels canned cycles, okay? Canned cycles are special cycles. We usually talk more about them when we move to the lathe portion of class. All right, G90, absolute mode. G20, here's another one we didn't basically talk about, but G20, the only two in the group are G20 and G21, and that takes care of inch versus metric mode. So G20 for inch mode. G17. G17 is plane selection. There are 3 G codes associated with plane selection: G17, 18, and 19. Since right now we are only discussing 2.5 axis millwork in the XY plane, yes, we want to make sure that the machine is in the XY plane. G17 is the XY plane. Okay. And we can put the machine in rapid motion, G00. That doesn't hurt anything. We can also make sure that all length offsets are off and all CDCs are off. G49 cancels length offsets and G40 cancels CDC. All right, so the entire group of CDC G codes are G40, G41, and G42. All right, and for right now, G43 and 49 are the only 2 you really need to know about. for length offsets. Okay, know that there are a few more within that group, and it depends upon the type of machine you're in front of. All right, but we are in front of a standard vertical machine with the vise under the spindle. There are several different configurations of mills. All right, but we are invoking in this direction. Okay, so that is a nice little header to make sure that your machine will operate in the right way for you. So we call this the header. Okay, and the header will make sure the machine functions for you the way you think it will. All right. Okay, so 1, 2, 3, 4. That is 4 common blocks. All right, 4 common blocks. And let's not forget good old M06 and a tool number. We all know what that one is, all right, if you've been here already, and most of you have been here at this point. All right, M06, now this is just the tool change. Okay. All right, so with these blocks of code, I could think of another one. All right, let's think of it is going to be G90, G54, X, Y. All right, G90, G54, XY. What does this code do for you? This code is called ensure the bed of the machine. That's the code terms that'll give this block of code. Absolutely, you're going to turn on your fixture offset, and then you're going to move the machine to an XY position that you know that is safe to invoke offsets. All right, so ensure the bed of the machine. And why do we want to do that? To make sure we are clear of work to invoke offsets. All right, that's why we need that block of code. And here, let me try to move this like so you can see that. I do that to all of them. Okay. So these are some common blocks that you'll use in every single program. As a matter of fact, of these blocks of code, 4 of them will get repeated every time that you need to get a new tool. All right, you don't repeat the header. The header is only used once, okay, in the beginning of the program. But the other 4 are used every time you get a tool. So every time you get a tool, these other blocks of code are always repeated. That's 90%, 95% of all programming. All right. Your other blocks of code come in for special situations, depending upon what is the definition of profile you're trying to make, or what is the feature you're trying to make. Like, are you using a can cycle? Are you using subroutines? The project that I asked you to make does have you using a subroutine. All right. So for that, we need to add a couple more blocks of code. M98, P, and a 4-digit number. 1, 2, 3, 4. M98 and a 4-digit number. That, what does that do? That will call to a subprogram. Okay, so it switches you out to another program. All right, in our case, the entire subprogram is going to be the definition of profile. All right, Okay. How do you end a subprogram? Well, we all know by labs 1 and 2, I had you observe an M02. What does M02 do? End a program. What does M30 do? It ends a program. You might ask, why do we have two? Why do we have M02 and why do we have M30? All right. Well, back in the day when we used to run these machines from tape drives, cassette tapes, you needed an M code to initiate the rewind. All right, the rewind on a cassette deck so you could play it again. Anybody that is of my era or have used a cassette deck before realize that even playing music, you needed to rewind your tape in order to listen to it again. Today's digital world, that is all gone away. You could just hit repeat and it repeats. All right, but hey, showing my age. All right, so how do we end a subroutine? A subroutine uses M99. That's a standalone code. All right, just like M02 and M30, it ends a subroutine. All right, so this is just a few of the blocks of code, the common blocks of code. All right, that you're going to need in the project that you do. You're going to need. I've memorized them. Memorize them. I'm telling you, I'm not lying. 95% of all programming will be done with these blocks of code. And this will end my recording here for now. And I'll have a couple more to help you with the program. All right, goodbye.